pressure wave. Okay, I think you have some firm idea. It will be okay. Let's get into this one. So what will happen to the wave when reflected? So how to get that rigid end and the free end? So here we take help of the thing called like a organ pipe, or so like I'll take a okay, fine here. So here what happened? There'll be a tuning fork. Who will push this particular signal? The tuning fork. Let it be here, and the tuning fork will send. So here the wave, the displacement wave will be incident. Okay, let me put it. The displacement wave. So this is what y1 I'll call it, and delta p1. Okay, now this I'll call it as rigid end, or it is also called as closed end. So we are discussing reflection at closed end. Let me pull this diagram a little bit down. Okay, fine. So reflection at the rigid or closed end is what will get this organ pipe. What is this organ pipes are what we have done? It's a cylindrical pipe. You can say like anything metal pipe. Pipe, or in pen you have the cap, no? The cap, that's what here. What will happen to this bottom of cylinder? Will it move? No, it will be fixed, no? So I'll call that as rigid end. Let me define it x equal to 0. Okay, a displacement wave is incident. We know some basic idea. If a displacement wave reflected by rigid end, what should happen to the reflected wave? The reflected wave will be like this. The reflected, this y, what is y2? Y2 is a reflected wave. So if you want, you write yi, yr. This will be, this symbols will be better, I feel. Okay, can we write reflected incident displacement wave? It is incident displacement wave. This is incident pressure wave. What will be the reflected wave? Any expression for reflected wave? Yr is equal to, what is the method? A sine omega t k minus x plus pi. Can you remember this? So this is what reflected displacement wave. Can you remember these things? Phase change of pipe, why? Because reflected by a rigid end. Why negative sign? Because after reflection, the reflected wave will move towards left. So therefore negative sign. So this will become is equal to minus a sine omega t plus kx. Then I want a reflected pressure wave, minus b dyr by dx. This should be equal to, so what is the equation? We'll get it here. Minus of, okay, this will become minus ak cos omega t okay, minus of minus, so this will become plus bak cos omega t plus kx. Okay, this is what we should call reflected pressure wave. I think this is a general idea, no? We'll get incident wave, we'll get displacement wave. Whenever a sound wave is incident, when a sound wave is incident. So what do we get here? Like a sound wave, how do we express incident displacement wave, pressure wave? Like this, we have some conditions, no? That's why we are trying to discuss what will happen to the nature of a wave, the pressure, what will happen, displacement, what will happen when affected by region. That's why I'm considering all these waves here. This is okay now. So like from where you have brought this? This is from transverse wave propagation. No, it is not a plus, it is a X, that one. Huh? From transverse wave propagation. Can you remember this? It may come with some phase. Okay, no problem. Add that phase plus pi and solve the thing. They may ask you very good conceptual questions here. That's why I just brought mathematically everything. Okay, this is clear now. Now, what will happen? Continuously, the waves will be incident here. And here what happened? Continuously, there'll be incident wave. Continuously, what happened? There'll be reflected wave. It's not like I'm sending a pulse. Are you looking at this inverted sign? Why inverted sign? This is very important. Please do notice this. What you send, no, you'll get like this here. The incident wave, it will get inverted. Any reason for that? Because of the phase change of pi radian. Okay, now these two will undergo superposition. Similarly, the pressure wave, it will get reflected. Okay, let's come for the displacement at closed end. Let's go for y is equal to yi plus yr. Let me add up. Let me take superposition of this incident displacement wave and reflected displacement wave. Yr is how much? A sine omega t plus kx. So let at x equals 0. So where do that closed end is located? Rigid end or closed end at x equals 0. Closed end at x equals 0. I'm interested what will happen to the layer of a medium which is at closed end. The closed end will become like a one layer. So for that, it will be put x equals 0. It will become a sine omega t. Okay, look at this one. What happened to the value of y? So the layer which is at closed end will not vibrate. There's a very important thing I'm concluding here. Rather than in books, the information is available. Just like the layer at the closed end will not vibrate. Why it will not vibrate? Now, how you measure y? Vertically or horizontally? Anybody want to reply back? How do we measure this? How do we measure this y? Horizontally or vertically? All of you sleeping or really listening my class? Because 6:45 maybe. Vertically. I want further. Please, everyone, please be alert. If you are really in sleepy mode, go wash face and come. Wash face and come, no problem. Wash face, and if you want to do brushing also, it should be fresh enough. Huh? Gradually, I think you should get adjusted to this time. Your college will start at 6:30. So physically, I want you to really get adjusted to the physical timings. That one. So I just started. That's why 6:45 started. Huh? Okay, no. Okay, one of the answer from Chandelier I got is like y is vertically. No, y is horizontal. Huh? This is very important. This y is how y is measured. Y is measured horizontally. I think I should make things clear here. It's a sound wave propagation. No, what is y? Displacement of a layer from mean position. So what will happen to this particular layer? It will not vibrate. It will be at rest at all the time. So therefore, if a sound wave is incident at a closed end, then what will happen to the closed end? The closed end will not vibrate. I think this is quite common sense, no? You just take a cap, pen cap will be there, no? It is similar to like a cylindrical tube or metal pipe. This one, you just blow air. What will happen to bottom of that cylinder? Will it vibrate? No, it is a rigid. No, it is a fixed. No, it will not vibrate. Got the idea? So this particular air will not permit it to vibrate here. So there's a rigid end. That's what it's telling. Let's see what will happen to the pressure wave. The displacement of the reflection of displacement wave is what we are discussing. What will happen to pressure wave? We'll see this one. So what is the conclusion as y equal to 0? Therefore, the rigid end will not vibrate. The rigid end will not vibrate with the time. Okay, this is what I'm putting the condition. Got the idea now? This will be okay. Let's talk about the pressure wave. So delta P equal to delta Pi plus delta Pr. Similarly, see, don't think that when you talk separately you are generating displacement wave, pressure wave. No, when you talk what happen, the wave will propagate. As the wave propagates, the layers will vibrate. The vibration of layers as a function of position time is what displacement wave. The pressure of medium varies. That is a pressure wave. The density of medium varies. To expressing that, the density will come. Okay, let's go for this one. So the superposition of this will be incident pressure wave. Look at here. This corner will be BAK. So this will become delta P of this is y of xt. If you want, you write it, or y of t, anything it will be. So there's like a standing wave. We'll get it 2BAK. What shall I write? 2BAK cos kx. Check mathematics. 2BAK cos kx cos omega. If I'm right, I'll proceed. Cos kx cos omega t. Is I'm right? Shall I proceed? Okay, fine. Yeah. This will be. Look at now. So put x equal to 0 because I'm interested at x equals 0. This is something very important. Let me just underline, highlight it. Yeah. What's happening to the pressure at the closed end? Is it constant or variable? Now you have complete description. Oh, no. Look at this one. The pressure at closed end, is it a constant or variable? No, it is in fact varying with the time. No. What is the maximum value of excess pressure here? 2BAK. Okay, got this idea? So therefore now I'll go for general conclusion at closed end. At closed end. What will happen to displacement? Y of t 0. So therefore, what should be the closed end? Shall I say note? I'll put it that one. Y of t 0. Therefore, the closed end. I'll do one thing. I'll write point wise. Huh? That'll be better thing. First, let me explain few things. No, let's come for this one. A displacement wave arrives, a sound wave arrives here. The displacement wave, what happen, will get reflected, will undergo phase change. Will I agree this? Yi, here we have negative sign. I'll put red color. This one. I'll highlight it. This is the incident displacement wave. This is a reflected displacement wave. Okay, got this one. Then what will happen to incident pressure wave? The incident pressure wave is this one, BAK cos omega t minus. What is the reflected pressure wave? Plus BAK cos omega. So is there any phase change? I'm asking, is there any phase change? No phase change. The pressure wave will not undergo phase change, whereas the displacement wave will undergo phase change. Will I agree, all of you? First, this is very important. I want you to think. Okay, that's the thing. So when a sound wave arrives at a closed or rigid end, the displacement wave will undergo phase change of pi radian. The pressure wave will not undergo phase change of pi radian. This is the one thing. Next, after this. Then what will happen to the closed end? Will it vibrate? No, it will not vibrate. What is the y displacement of this layer, the closed end bottom of cylinder? Why do it will vibrate? It will not vibrate. There's a common sense. You blow air into the some in any cylindrical pipe. Will this vibrate bottom? No, it's rigidly fixed to this can, no metal can. So therefore it will not vibrate. So therefore this should be a node. So what is a closed end will become displacement node. But what happened to pressure at that point will vary harmonically. How much maximum pressure, how much maximum excess pressure will be 2 BAK. So therefore, what will happen to the closed end? Closed end will become a pressure anti-node. That's what I'm calling. The reason for that, because pressure is varying and it varies harmonically with the time. It in fact varies harmonically with the time here. So therefore, what are the conclusions I can make it here? The conclusions are at closed end. The displacement wave will undergo a phase change of pi radian. The closed end will be a displacement node. This is the one thing. Next again. Next again, the pressure wave will not undergo any phase change. What about the closed end? The closed end will be a pressure antinode. Okay, I agree this. So these are the some points which I'm summarizing. So the closed end should be displacement antinode. Okay, let's come for this one. What do we have? Here the plus BAK. Plus BAK means what happened? So shall we say compression? And what do we are getting? Again, the reflected wave is a plus BAK. So shall we say that the closed end, at the closed end, if a compression arises, if a compression arrives here, the reflected will be compression. So nature of sound signal will not change. What do you mean by nature? Compression rarefaction is what we express, no? The sound wave propagation. Here, the incident pressure wave is what? Compression. Let's assume that one. The reflected wave is also again plus BAK. What do you mean by plus BAK? Maximum pressure, where the pressure is maximum, P naught plus BAK should be compression. If there is a P naught minus BAK, it should be rarefaction. So therefore, a compression will be reflected as a compression. Rarefaction will be reflected as a rarefaction. So there's a one very important things I'm going to conclude. Next one more. The nature of sound signal will not change. The compression is reflected as compression. and rarefaction as rarefaction. What is the meaning of this? So I'll express through the diagram. If there's an organ pipe, if a compression arrives here, if there's a rarefaction, some different colors, compression, I'll give this as compression, rarefaction, some other colors, let me give. Now what will happen is, this is the compression will be reflected as compression. This is the incident. Okay, don't call yi. There's the incident. This is a reflected. And rarefaction which arise will be reflected as rarefaction. This is at where closed end. Okay, that's why we just put it in a very simple way. What is that? The nature of sound signal will change. A compression will be reflected as compression. The compression is reflected as compression, and rarefaction as rarefaction. And what is this? This should be, what is the conclusion? Displacement node or pressure antinode. Okay, now the excess pressure is varying harmonically. So what is the value of maximum pressure here? The maximum pressure at closed end. Shall I write P naught plus 2BAK? Agree this? The pressure will become how much? P naught plus 2BAK. Similarly, what is the minimum pressure? Okay, the pressure at closed end will vary about mean atmospheric pressure, will fluctuate harmonically about mean atmospheric pressure. So when at one instant it can be cos omega t can be equal to 1. So maximum pressure will become P naught plus 2BAK. Minimum pressure will become P naught minus 2BAK. But what happened to displacement will be 0 at all the time. Any doubt if you have, you can clarify. This is about the reflection at the closed end is what we are studying it. Okay, fine. So let me go for reflection at the open end. Let's take the next page.